results is what we did on Friday. Do you remember that? Actually, I take that back. We reviewed solving trig equations, proving trig identities, and then we introduced t-results. So just in case you're a little bit fuzzy on it or you weren't physically present, okay? The idea was we introduce this tan of theta on 2 or x on 2 or any angle on 2, really. We call it t, and we use that kind of like a common denominator for all our regular trig functions, okay? So just like, I think the analogy I gave was if you added two fractions like this, okay? In order to get them to talk to each other, interact, you need a common denominator, namely, in this case, a 12th, right? So this will be 3/12, this will be 2, and then you can get your answer, right? So this is kind of like our common denominator for sine, cos, and tan, right? Now, I just sort of, remind me, I think I derived the results, but we didn't really take it anywhere. I just showed you what they were. I'm not going to go into the proof because you can go back on the video and do it yourself, but what are the results? Going from tan, you start with tan, yeah.
Isn't it meant to be 5?
Yeah, that's 5 for
Yeah, I'm doing well today. That's what I get for skipping lines of working. Okay, now you start from here and you say, well, okay, what will your other identities be? Think about your double angle. Okay, so here's where I'm going to do spoilers. So regular old tan theta, or x's or alphas, it doesn't matter what you use, okay, is going to be in terms of this, but double angle, right? So regular double angle is 2 times that tan ratio, but we just shorthand call it t, on 1 minus t squared. Okay, just ringing bells. So you're used to reading this as tan 2x is 2 tan x minus 1 on 1 minus tan squared x. Okay, all I've done is just rephrase it a little bit. Now from there, we use the same idea and we said sine is going to be 1 minus t squared, sorry, wrong one. 2t on 1 plus t squared, and cos is 1 minus 1 plus. Happy with that? Remember that? Yes? Now, I stopped short of actually saying how can you use this, but hopefully my introduction to the lesson, looking at equations and looking at identities, gave you a bit of a clue as to, okay, well, how can you actually use it? So here's my first example. It's the only one I'll cover today. I gave you tons of work last lesson, so I'm going to, after I finish with that, let you get on with it. How would we do this normally? Let's think about how we would do it normally. Tan 2x cot x. Actually, I'll just start with the left-hand side. If we were to treat this just like a normal identity, right? I think generally we think about what identities we can use. We bring things down to the basic, sines and cosines, and then you just bash it out from there. Okay, so let's give this a go. The first thing I see that's easy to break apart is that tan 2x. Okay, so just like before, use your double angle formula. So up on the top, that's going to be 2 tan x. That cot x, I could break it apart, but I'm going to leave it, as you'll see why in a second. Cot x on 1 minus tan squared. Okay, so far so good. Now the reason why I left the cot in its place is because tan and cot are reciprocals. So these two are just going to cancel out, right? So I'm going to get 2 on. Now, I might as well deal with the denominator as well. That tan squared is sine squared on cos squared, right? Now, thinking about where I'm heading, right? Where my right-hand side is, what my goal is, I'm going to have to undo my double angle formula in a second, okay? So I'm having to think about how I can reshape this so that I'll end up with a 2x here again. Because I've brought everything down to single x's, so I've got to go back, right? So where my brain goes is multiply everything through by cos squared, okay? Now maybe you're like, As I do that, hopefully you'll see why, but I know to do that because I've done questions like this, hundreds and thousands of times, but it might not be so obvious to you, okay? So what will I do? Multiply through by cos squared. This is going to become cos squared, and this is going to become sine squared. Now hopefully you can recognize I've got this is cos 2x, that's the sec 2x that I'm after. Does that make sense? But again, that might not be so obvious until you sort of gone around in a few circles for a while. Okay, now I'm going to keep that in mind. What do I do with the top? Now, a few different ways to think about it. Here I think is the most obvious way. I'm going to take those two cos squareds and pull them apart. So cos squared x plus cos squared x, okay? And on the bottom here I've got my cos 2x like I said before. Now, why did I bother saying 2 cos squared x is cos squared plus cos squared? Because, just in my brain, it makes it a little more obvious that 1 cos squared, I can sub that out for 1 minus sine squared. Remember that? That's the Pythagorean identity. So, cos squared on the top plus 1 minus sine squared. You see where I'm going here? All on cos 2x. Now, even though they're separated by +1, maybe I'll just move that +1 along the end to make it a little more obvious. Now on the top, I've got my cos squared minus sine squared. So again, cos 2x minus 1. Okay, now I'm basically there. Okay, that numerator I can just break it apart. Cos 2x on cos 2x is 1. 1 on cos 2x is sec 2x, and I'm home.
It was +1.
Okay. Oh, sorry. Thanks. Great. Okay. So you happy with that? Now, you might have taken maybe 1 or 2 more lines extra to do that, because some of these steps, for instance, at this point here, I was like, bingo, I exactly know where to go, because I've done questions like this, and because I have my eyes on the prize, I know exactly where I'm headed. Okay. But it might have taken you a little longer to get there. Also, you got your double angle up here, and here, that's a bit weird. Maybe you saw this identity a little more obviously, a little more straightforward. It didn't jump out at me. I had to break it apart to see it, you know, that kind of thing. But this is kind of emblematic of how, when you get a trig identity like this, parts of it are just sort of leaps of, conceptual leaps. They're like, well, if you see it, you see it. And if you don't, you just kind of scratch your head for a little while, right? The t results are about taking that guesswork out, okay? So this is how we would do it using our regular identities. How would we do it with t results? Well, take your equation here, have a look at it, and the first thing you do is think about what kind of substitution should I make? Okay. Now, I said right at the beginning that we usually say this, tan of x on 2, right? So it's a good try. It's a half angle result, right? And you can see here I don't have any half angles. What I've got is double angles instead. Okay. So what I'm going to use is, I'm going to start off by saying let t equal just a single tan x, no half angle. Okay. Now what that's going to do is it's going to double all of my angles, right? It's going to double all of them. So therefore, tan 2x. This is just my regular old double angle formula. This is 2t on 1 minus t squared. Okay, can you see where I get that from? It's just the double angle formula. Now the next thing to think about is, look at the identity, both sides. Okay, look at all the pieces that I've got left. All you need to do is write each one in terms of the t formula. Okay, so tan 2x, already got that one, tick. I've got to get cot x, and I've got to get sec 2x. All right, let's think about cot. That's an easy one. Cot's the reciprocal of tan, right? So therefore, cot x is just 1 on t. Is that right? Makes sense? Sec 2x, sec is 1 over cos. So let's just think about cos first. Cos 2x will be, how good are you with your memory? What's the t result for cos? 1 minus
t squared
on the top, 1 plus
plus
on the bottom. Okay, I know this is the extra work that t results gets, but hopefully it'll be justified in a second. Now what I want is not cos but sec, so I just flip it upside down. Okay. Now I've got all my pieces. 1, 2, 3. Now, pay attention here for a second. Last lesson when we talked about proving trig identities like this, we said you've got to go from one side to another. You can't sort of stop at some middle point, okay?
Wait, so can we meet in the middle for this?
The exception to the rule is t results, and you'll see why in a second, okay? So with t results, you can go to West Pennant Hills, okay? And those of you who went here in front of you, you'll be like, huh? Okay? Alright, so here's what I'm going to do. I've got all of my substitutions ready. It's sort of like I think of this part like on a cooking show, right? And like Jamie Oliver's there, and suddenly everything is all pre-cut in bowls, and he just chucks it in. Like, no wonder he can do 15-minute meals. Anyway, so here's your pre-setup. Okay, it's a total lie. I tried 30-minute meals once, and it took me like 1.5 hours. Anyway, I've got them all set up. Take one side, evaluate and simplify. So let's do this. Let's do the left-hand side. Tan 2x cot x. That's going to be this one. 2t on 1 minus t squared times 1 over t. That's the two pieces. So what can you do to that? Not much. Those t's cancelled, and that's where you finish. That's as simple as it gets, right? So you stop. Then you look at the other side. That's 1 plus sec 2x. Okay, so 1 plus that one over that one. Okay, so that's just a fraction. You add them together. So 1 minus t squared plus 1 plus t squared on 1 minus t squared. T squareds cancel. And then you go home and laugh at the people who still have to do this. Okay, so that's it. That's it. Now, when you look at it, like next to each other, okay, they do look about the same. Okay, you do have to do this pre-setup before you actually get into your proof. But for certain kinds of identities, this is so much easier. Like, look at this. Not only is it less lines, but they're easy lines, right? You don't even have to, you almost don't have to think, because you guys have been doing this for years now. Whereas this, it's sort of still harder. Even for after doing this for 2-3 years, people can still be quite poor at this because they don't see the conceptual leaps between different lines, and they're just like, I don't know. Okay. So there's just one example on the sheet that I gave you, which looks like this. So I think the knockout people I think got it because I think Ivy picked it up for everyone because Ivy's awesome. Anyone else who didn't get it, or maybe you misplaced yours at home, grab it out. What you can do is, exercise 5C, see how it says prove the following identities, okay? You can prove them whichever way you like. I'd actually like you, for some of the later questions, to, for example, let's do question 5. Question 5, A, B, C, D, there's 4 parts, okay? I'd like you to do them both ways. I'd like you to solve them both ways.
Double the work.
I know that seems like double the work, right? But the point is, so that you can see, sometimes you choose one, it's a good idea to actually do it the original way. Okay, sometimes T results doesn't save you any time because doing all this, it's like, oh, there was some simple identity that just made it come out. Now, your ability to choose which one's faster, it only comes in practice. I can't give you a rule like, you always use it with this kind of problem. You just sort of have to practice. Okay.